Hello and welcome to this video. This is going to be one of four looking at this DIY Arduino Data Logging Shield. I put together an Instructable, so if you want to see how this was put together, please have a look at that. The link is in the description. So this shield, basically, it has this blue board here. This is a microSD card reader. So this board itself has a microSD card reader right there. These run on 3.3 volts, and Arduino runs on 5 volts. The Uno runs on 5 volts. So it has a 3.3 voltage regulator, so it won't get damaged by the higher voltage. It also has this buffer or level shifter. So this chip allows communication between the Arduino and the card reader at the appropriate voltages without damaging anything. Over here, this chip, I don't know if you can see it. This is a DS1307. This is a real-time clock chip. Here's the top of it. So here's pin 1, 2, 3, 4, and then 5, 6, 7, 8. So this keeps track of time, and I've set the time on it. It has this backup battery, so although this is not plugged into anything, it's still ticking away in the background and keeping track of time. When I plug this into the Arduino, then I'm able to access the time from this chip. And so that allows me to create a timestamp that will go along when we log our data onto the microSD card. This chip has a few supporting components. So this silver looking thing, that's a crystal oscillator. So it sends ticks at a regular interval to help keep track of time. This chip uses I2C communication. So there are two pull-up resistors as it communicates to the Arduino. Of course, this module here uses SPI communication, hence the different pins here. A couple other things, there's a couple switches for options for powering this. I did have some challenges, powering this so that it would work properly. So there are some capacitors on here, one here, and then there's one over here. So if you would like to see more information on that, please have a look at the Instructables. But for this video, I just wanted to demonstrate data logging with this shield, and I thought I would choose a simple sort of event monitor. And so I've chosen this. This is a 4133. It's a Hall effect sensor, so it senses magnetic fields. It's a digital sensor, so it doesn't sense the strength of the magnetic field, it just senses the presence or absence of it. And so I'm going to put that on a breadboard. It does use this pull-up resistor between the output and the high voltage pin just to help keep the output stable. So let me just put that together. So let's put that right here. So this, like I said, this pin on the left is the VCC high voltage. So I'm going to put that to the 5 volts of the Arduino. And then the middle pin is ground. It's not connected to the resistor. There's a ground pin over here, so let's take advantage of that. And then the output, I'm going to put to pin 2 over here. All right, so those are our connections. Like I said, it's an Arduino shield for an Uno. I guess I should have put that on first, but let's put that on. So you line the pins up. So I made this a long time ago, and it has the stackable headers. So that way all the pins now are on the shield are connected to the pins on the Arduino. But I don't like stackable header pins. I mean, maybe I bought the wrong ones, but I find them flimsy and they bend easily. So the alignment, it comes out of alignment. But anyways, that's our setup. So so my idea for this sort of example is like a door monitor that senses when the door is opened and closed. So if this sensor was, let's say, mounted on the door frame and you had a magnet, here's a magnet, okay, and you mounted that on the door, then when the door is closed, they're close together, and then when the door is open, it's moved away. And so then this magnetic sensor can detect when the door is opened and closed. So this is kind of getting in the way of my field of view here, okay? So that's it. So let me just show you the code. So let's go to the computer here. So if you want a copy of this code, you can go to the Instructables, and under Demo 1, you'll find this. You can download it. I do kind of expect that you have some familiarity with Arduino already, but just to kind of give you a orientation to this. So like I said, the real-time clock, the RTC, uses I2C, so it uses the wire library. And then this is the library I use as background programming for the RTC. It's a URTC lib. So I suppose that's micro RTC lib library. So there's a link for this in the Instructables. So I found that when I was putting different components together, I was running out of space for the programming and the memory in the Arduino. I found this library to be a little smaller, so that's why I'm using it, and it works well for what I'm doing. Then here we're just creating like a real-time clock object, so that way whenever we refer to our clock in the programming, we have to use this. Like I said, the SD card, the micro SD card reader, uses SPI communication, so we need the SPI library, and we're going to use the SD library, which is part of the Arduino IDE. So in SPI communication, there's a CS pin, chip select pin, and so each SPI device would have its own pin. So I'm going to use pin 9 here on the shield. And then, like I said, we have our magnetic Hall effect sensor. So we're going to attach that to pin 2. Okay. And we're going to detect whether the door is opened or closed. So that's perfect for Boolean type variables. That's what bool is here. So we're going to use it as sort of our flag. So if the flag is high, then that means the door is open. So door open flag, right? So a Boolean can be either a 0, which is the same as false or low, like low voltage, or 0, or it can be 1, which is high or true. But anyways, we're going to be using that in the sense of 0 and 1 as our flag. Okay, and then really what we're looking for is when it changes. So because we're looking for that change from 0 to 1 or 1 to 0, we need another flag to compare to. So we have a previous flag, prev flag, and so when these are different, then we know something has changed. Either the door is opened or closed. And we're going to save that time and date to our micro SD card so we can see when the different events happened. So because of that, then we have to write whether it's open or closed. And so we're going to use this array of 2 elements, okay? And our 2 elements are closed. So the string, the word closed, and then opened, okay? And by the way, if you know about arrays, they start counting at 0 and they go up from there. So an array of 2 elements would have 0 and 1 as the 2 elements, okay? The index for the 2 elements. And so that becomes important later when we are writing to the data logger, okay? Here, there's serial begin. So this is just for the demo here that I'm showing you, so you can see when it's running that it's what it's doing. Also, if you're using this and you're troubleshooting, it's very helpful to have these serial statements printed to the serial monitor on your Arduino IDE. But once you get it set up, then you can actually delete these because your data logger won't be connected to your computer, and really these serial statements just slow everything down. But like I said, it is useful when you're troubleshooting. We're going to start the I2C communication with our RTC. So that's what we're doing here. This line here I kept in here. This is actually how you set the real-time clock. I've commented it out so it won't actually be included in what's uploaded to the Arduino. But that's what this line is for. If you look in the Instructables, I kind of explain a good way to set the accurate time using this. This line too is also from the micro RTC library. And I just keep this in here because it reminds me what each of these numbers mean. Okay. Okay. So this is for the SD card. So again, we're sending serial print statements so you can see what it's doing, where it is in the program. But now we're going to set it up. So we're going to set our chip select pin as an output. And then we're going to begin the SD card reader, the micro SD card reader. So this not statement means that if this is not true, meaning it didn't work, then we're going to send a message to the serial monitor. and then end the program. Otherwise, if this is not true, meaning it did work, then we're going to send the note that it was ready. And then here we're going to, with this line, open our file. Okay, so this line, what it does is it either creates the data file in the microSD card, or if it's already there, it opens that file already, and it's just going to add to it, to whatever's in that file. Okay, so now that we have our file open, so if log file, meaning if it worked, okay, if this is true, meaning this worked, then the first thing we're going to write to the log file, so we're going to write to the file itself, is just this series of commas and spaces. And effectively what this does is it puts a blank line in our file. Okay, I guess I should have pointed out this CSV stands for comma separated values. So that means that this file, each value is separated by a comma, so you know where one ends and the next one begins. These kinds of files can be opened by spreadsheets programs like Excel. They can be opened by text file editors like Notepad. Okay, so anyway, so this blank line, what it does is it lets me know if I've restarted data logging or if there was power loss and it came back on. Then I can see that that's where it started up again. Okay, and then the next thing it prints is the headers for each of the columns. So I know what each column in here represents. So month, day, hour, minutes, seconds, right? So our logger is only logging down to the second. And then this door to let me know if the door was opened or closed. Now that I've printed to my file, then I want to close the file. Okay, so this is very important. If the file is open and you lose power or you turn it off or the battery dies, then actually what happens is you lose all the data in the file. So if you've been collecting data for 2 weeks, you've lost all 2 weeks of that data. The file gets corrupted. Here, I'm just sending the confirmational statement to the serial monitor to show what was printed in our file. Okay, but if this is false, meaning it didn't work when we tried to open the file, then we just get this note down here that it didn't work. Okay, and then we end the program. Okay, so that's end of the setup for the microSD card reader. Here's for our magnetic sensor. So we're going to set that pin to the Hall effect sensor pin as an input. Remember that the sensor itself has a sort of pull-up resistor on it, so we don't have a pull-up here, but that's what we're doing there. And then these two if-else statements. So what this does is it sets it up depending on whether the door starts opened or closed. Okay, so to do this, we check the pin, see if it's high, and if it's high, then we're going to start our flag, our door open flag at 1 because it's open. If it's not high, if it's low, then we're going to have this else. We're going to set the flag at 0 because it's closed. And because we're starting off, we're going to set our previous flag the same as our door open flag. Okay. This last line in the setup, this is attach interrupt. So the way we're employing this sensor is as an interrupt, as an external interrupt. And again, it's on pin 2. So digital pin to interrupt is the Hall pin, which is pin 2. And the way it's set up is if the state of that pin changes, either high to low or low to high, then, okay, so if it changes, then we're going to run this program, interrupt function, which is a function that we set up. So the way interrupts work is wherever you are in the programming, if a change occurs on that pin, then it's going to run this function and then go right back to where it was in the programming. So if you had a lot of programming in your Arduino and you didn't want to miss when a change occurred, that's what these are good for. Okay, our programming is only set up to log the data, but at least this just helps in case we add more to our program. So here's the loop, but actually let me skip down and show you what this function is. So it's at the very bottom. So here it is here, interrupt function, okay? And it has basically one line. So it takes the door open flag, and it makes it equal to not door open flag. So whatever the flag is right now, it just changes it to the opposite and saves it. And that's all this interrupt function does. Okay? So regardless of where you are in the loop, you know, if you're up here or down here, basically, there's only because there's nothing else in our loop right now. It'll call that function. Okay, but if we added more, if our data logger was doing more, then we wouldn't miss that change. Okay, but if it does change, then when we come to this if statement, it compares if the flag is not equal the previous flag. Okay, so if these are different, then we know some event has occurred. Okay, and so now we're going to figure out if the door's opened or if it's closed, what the date and time is, and then save that to our card. So that's what this whole if section is for. Okay, so the first thing we do is actually we turn off our interrupt. So that way, while we're collecting our data and saving it, you know, we can't trigger it again, which is fine for this because it really doors opening and closing don't happen, you know, 1,000 times a second. So it should be fine that we turn the interrupt off. However, if something is glitchy or, you know, it misses whether the door opened or closed, then this section here, which is the same as above, will help correct for that. Okay, so to check the pin, if it's high, that means the door is open, so we set our flag high. If it's closed, this will be low, so we set our flag 0. Okay, so that way, if we do miss something, okay, we lost that data, but at least now we're back on track again, whether the door's opening or closing. So now that we've determined that an event happened, we call this RTC refresh. Okay, so this line is from that urtclib library. And this command, what it does is it accesses the date and time from the real-time clock. And it stores those values into the Arduino. Okay, so we want to call this function close to, you know, whenever our event occurred. So it occurs early in this if statement area. And then here we're going to create a data string. Okay, so the values from the RTC, they're integers. Okay, they're numbers with a certain value. But what we're going to save to our file are not values, but a series of characters. Okay, so that series of characters is a string, and that string we're going to call data string, so we know sort of how to refer to it. And basically, what it is it's a bunch of you know, the values, sort of not the values, but the date and the time and everything separated by our commas. Okay, so this string sort of function converts the value of the month from the RTC to a string. Okay, so this integer is now converted to a string. So for example, if it was December, it's saving it as a 1 and a 2. Okay, and then we put in a comma, and then the day, then a comma, hour, comma, month, comma, second, comma, and then this is our array, okay, our door state. And remember, it has 2 elements, closed and open, and closed is our 0th element, and open is our, you know, element number 1, which is the second element. I know it's confusing, but we use the flag now to determine which of those we write in our data string. Okay, so now we have our string. So now we can actually go to recording. So here we're just sending a note to the serial monitor, and then we open that file again. So this is the same as above. We have to call it the same name. Otherwise, we're going to create a different data file. But this is the same. We're going to open that same file again. And here, same thing as above. If that worked, then we're just going to write our data string as is, and then close the file. And then just to confirm, we'll print it out to the serial monitor. If it doesn't work, then we're going to send that note out to the serial monitor, okay, that it didn't work. Okay, we weren't able to save. This is serial flush. What this does is it empties the buffer. So if there are any characters left in the serial monitor buffer, it would get rid of it. It's not really necessary here. It's kind of a holdover from a previous a project I had where it was going to sleep, but you wanted to make sure the buffer was empty before you go to sleep. So again, you can get rid of this. I just kept it in here in case I use this code for something else again. But anyways, that's what that does. Last thing we're going to do is going to update our previous flag so it's the same as our current door open flag. Okay, and so now that they're the same, we won't record data again until another event occurs. Okay, so that's our programming. So let's plug in our Arduino and upload this, because I don't think I have it uploaded. So let me just upload this. Okay, so I've inserted my microSD card. Here's my sensor there. One thing I should point out is these sensors are polarized. So if you look at this magnet, that hole is countersunk there, and then here is flat. If we open the serial monitor, so it's kind of resetting everything. So if there's already data in there, it's actually just reset it again. So it's starting from scratch. So there's that blank line and then the header. But we see that the card is ready, and it's now ready to go. So like I said, so this side of the magnet, if I bring it close, of course it's pulling everything together, but you can see from the serial monitor nothing happened. So just make sure that you have the right side for your magnet. I guess if I came from the other side, that wouldn't work, but this is the right side. So if we bring this in front, if you look at the serial monitor, okay, we can see March 26th, 9:22 a.m. and 24 seconds, the door was closed. Okay, and then if I move the magnet away, okay, at 35 seconds, the door was opened. Okay, and so that's how our data logger is going to log those lines. Okay. If you go super fast, then yeah, you probably can get a glitch and you'll get two open statements or two closed statements. I guess if you could open and close it faster, then it can write to the SD card. Then it would cause a glitch. But at least it would correct itself. Okay, so there's some data. So let me just show you what we see in the card. So let me turn our power off here. Okay, and my computer has a slot for an SD card, but not a micro SD card, so I need to use this adapter, and let's put that into the computer. So this here is the micro SD card, so let's open that. And I've been playing around with it, so there's actually two files here. This is for the next demo, but this is the file that we just added to. So you see, I was playing around with it yesterday, so on the 25th, but here's today's. So March 26th at 9:22 a.m., 24 seconds, the door was closed. Okay, you can see open, closed, and what time those things occurred. Okay, so that's data logging events with a real-time clock timestamp. So I hope that was interesting, useful. Feel free to take the code, play with it, okay, use a different kind of sensor. In my next demo, I'd like to show an analog sensor, something simple again, data logging at regular intervals. Okay, so I hope that was helpful. Thanks for watching.